Hi guys, and welcome to Intro to Rigging for Beginners. In this video we'll go through all the fundamentals of how armatures work in Blender. The video will cover all the basic concepts and we'll run through how each step of the rigging process works. I won't be going into advanced topics this time around, and instead I'll just keep things simple so you can learn the basic principles first. In future videos we'll cover more advanced rigging topics and techniques, so stay tuned. Before we start, just make sure to turn on some settings in Blender so you can follow along. Go to Edit, Preferences, and go into Key Map. Here turn on Tab for Pie menu and Extra Shading Pie menu items. Then in Input, turn on Emulate 3-button mouse. After that, press down here and save settings. Okay, now let's get started. First we'll go through some basic rigging concepts, and then I'll give you a little demo for all of them. So what exactly is an armature? An armature, which can also be called a rig or a skeleton, is a type of object used for rigging. The armature is what allows the 3D objects to deform and move. Armatures are made out of bones. These bones can be moved or rotated around, and anything that they're attached to will move and deform in a similar way. The bones, like the bones in a real skeleton, dictate how the skeleton moves and where exactly it bends. Bones work in a hierarchy. To visualize how the hierarchy works, think of it kind of like the branches of a tree. When one bone is below another bone in the hierarchy, that makes the bottom bone a child and the top bone a parent. The child bone inherits values from the parent bone. To go back to our tree analogy, this is exactly like the branch of a tree. If the bigger branch moves, the smaller branches on it will move as well. So what are the steps in rigging? Step 1 is to create your armature. In this step you create all your bones and define the relationship between them. Step 2 is to skin your mesh to your armature. Step 3 is painting weights, which define how your mesh deforms. Step 4 is creating controls for your bones for easy animation. Now let's talk about the process in detail. First we'll have a look at parenting bones. Bone parenting allows you to make a certain bone in the armature the parent object and another bone the child object. Parented bones in Blender can have two types of relationships: a connected relationship and a keep offset relationship. The first type is a connected relationship. This is when a child bone is directly connected to its parent bone. In this case, the child bone can't be moved from the parent. However, it can still be rotated and scaled. To parent two bones with a connected relationship, select the bone you want to follow first, and then shift select the bone you want to be followed second. Then press Ctrl P and choose Connected. The child bone that is on top can only be rotated and cannot be translated independently from the parent bone. The second type of relationship is a keep offset relationship. In the keep offset relationship, the child bone keeps its offset and can be moved independently from the parent bone. It still also inherits the rotation, location, and scale from the parent. To parent two bones with keep offset on, again choose the one you want to be a child first, and then choose the parent bone. Press Ctrl P, and this time choose keep offset. Now this bone is parented to this bone, but it keeps its transformations. This means they can still be independently moved from the parent bone and the whole chain. So that is the two types of parenting you can do with bones in Blender. Let me tell you a bit more about when you would use each one of these and show you them side by side so you can compare them. Both types of parenting relationships have their own uses. You would use the connected bone relationship where you make a whole chain of connected bones when you have something like the arm of a character. In this case, it makes sense to use a connected bone chain because you don't want the animator to be able to translate the forearm bone away from the upper arm. Generally, you use connected bone chains for the spine, arms, and legs of a character. You can use the offset bone relationship when you want a bone to be parented to a certain part of the skeleton, but still be able to move completely independently. That would be for more things like props or things that need to be moved independently from the main rig. Okay, let me explain the next step of the process now. After you're done building your rig, the next step is skinning. Skinning is the relationship between the vertices of a mesh and the bones of an armature. The skinning defines how the transformations of each bone will affect the position of the vertices when the bone moves. When you skin a mesh to your armature, you get what is called skin weights. Skin weights define how much influence a specific bone has on each vertex. The influence is defined in a range from 0, no influence, to 1, maximum possible influence. Blender uses a color band that maps the weight of 0 to a dark blue color and the weight of 1 to a red color. So what you see here means the selected bone has no influence over the dark blue areas, and the bone has 100% influence over the area in red. Other shades of blue, green and yellow are also used to indicate how much influence a bone has over the mesh. The next thing I want to mention is that skin weights in Blender are organized in vertex groups. You can find the vertex groups of any object by selecting it and going into Object Data Properties, Vertex Groups. So what are vertex groups? Simply put, vertex groups are a selected collection of vertices. Vertex groups are the way the Blender limits the effect of the bones to only a certain part of the mesh. Once you skin a model, you get a unique vertex group for each bone. That vertex group dictates what area each bone affects. In these vertex groups is where we assign each vertex a skin weight. When it comes to skinning, you have two options. You can skin an object with automatic weights, or skin your model to a specific bone. The fastest way to attach your armature to your model is to skin your model with automatic weights. When you skin with automatic weights, Blender creates a vertex group for each bone in the armature and assigns skin weights to the vertices based on their distance from each bone. So it does all of this automatically. You do usually need to do some tweaking where Blender hasn't done a good job at assigning the weights, but it does get you most of the way there. The second option is you can skin objects to specific bones. To give you an example, this is useful for when you're doing something like a helmet and you want it to be only skinned to a specific bone, in this case the head bone. Now it's time for our demo. I'll give you the shortcut so you can follow along if you like. First, let's add an armature to our scene. Press Shift A and go into Armature, Single Bone. Now we have an armature object added to our scene. If we go to the hierarchy here on the right and expand the armature, you can see the one bone our armature consists of. You also have the pose, which stores animation data for each bone. In Blender, all of the bones sit under one armature object. Bones in Blender can be edited in Object Mode, Edit Mode, and Pose Mode. In Object Mode, you can't move the individual bones. Instead, here you move the whole armature as one object. Usually, you don't edit bones in Object Mode at all. In Edit Mode is where you add new bones and adjust the positioning and relationship of the bones. In Pose Mode is where you do your posing and animation. Now let's start a chain from this bone. In Blender you extrude the bones like we extrude meshes. Press Tab and go into Edit Mode. Select the bone and press E to extrude it. Now these two bones are part of a connected bone chain. You can see here in the hierarchy on the right that one bone is below the other. That makes bone a parent of bone.001, which means that when you move bone, bone001 will follow. If you move the bones in edit mode now, nothing will happen. That is because we have to be in pose mode to see the parenting in action. Press tab and go into pose mode. You can see now that bone001 does indeed follow the movement and rotation of bone. This is because bone001 is a child of bone. The child is not able to be moved independently because this is a connected chain of bones. Let me show you how to duplicate bones now. Press Tab and go back into edit mode. Select this bone and press Shift D to duplicate it. That makes bone 002. Now let's duplicate this new bone another time. Press Shift D to duplicate it. Move it up here. The bone chain we have on the left is using a connected relationship. What I'll do on the right here is parent these two new bones with a keep offset relationship. To do that, select the bone you want to be a child first and then select the parent second. Then press Ctrl P and choose keep offset. Now you can see here we have a little dotted line between the two bones. That means that the bones are parented with keep offset on. To see this all in action, press Tab and go into pose mode. You can see here the top bone of the chain on the right can be rotated and moved independently while also moving when the parent bone is being moved. This is because of the keep offset relationship. The chain on the left behaves differently. You can only rotate the top bone, but you can't translate it. That is because of the connected relationship. I hope this explains the difference between the two clearly. Another cool thing you can do in Blender is that you can subdivide bones like we subdivide meshes. Let me just add a new bone so I can show you. Press Shift D to duplicate one of the bottom bones. Move the tail of the bone all the way up here with G and Z. Now you can subdivide this bone by selecting it, then right-clicking and choosing Subdivide. From the little menu on the left here, you can choose the number of cuts you want to give your bones. Subdividing bones is great if you want to make evenly spaced bone chains. The bones in this chain by default have a connected relationship. If you wanted to change this connected relationship to a keep offset relationship, you can do that too. To do that, press Tab and go into edit mode. Select the bones you want to disconnect from the chain. Let's select these top two for example. Now press Alt P. You have two options here, clear parent and disconnect. Choose disconnect for now. Now these top two bones have been detached from the chain and instead of a connected relationship, they now have a keep offset relationship with the rest of the chain. So now they can still be moved independently in pose mode while still inheriting data from the main chain. You can also completely detach a bone from the chain if you wish to. To do that, select a bone, press Alt P and choose Clear Parent. Now this bone is completely independent from the bone chain. There's no parenting on it and he's as free as a bird. The last thing I want to show you is you can also change from a keep offset to a connected relationship the exact same way. That allows you to connect a bone back onto the chain if you need to. Just select the child bone first and then shift select the parent bone. Then press Ctrl P and choose connected. That attaches the bone back to the chain. If you want to start another bone chain that's completely independent from the first one, you can press Shift A. That makes a separate bone, which although still connected within the armature, is not connected to our previous chain. It moves completely independently. Another thing I want to show you is how you can mirror bones. Using Symmetrize allows you to mirror your bones and it's a great way to make your rig building faster. If you want to use Symmetrize, your bones need to have specific naming. The naming your bones need to have is .L or .R depending on which side the bone is on. Let's name this bone bone.L. After this, go Armature and choose Symmetrize. As you can see, Blender has now mirrored the bones with symmetry on. It also renames the new bone to the correct suffix. If your bones have a name that doesn't end in .L or .R, Symmetrize will not work. So do make sure that all your bones are named correctly. A great thing about using Symmetrize is that you can now edit your bones with symmetry turned on from up here, which really speeds up your process of making rigs. Now let me show you the skinning process in practice. I'll just make a new scene for that. First, let's add a new armature to the scene. Press Shift A and add a single bone. Then select the end of the bone and move it up with G and Z. Right click and choose Subdivide. We'll add 2 cuts to the little menu on the left here. Now let's add a model to the scene. Press Shift A and add a cube. Press Tab and go into Edit mode. Move the cube up with G. Then select these top vertices and move them up as well with G and Z. Now let's change the viewport settings so we can see our bones in front of our mesh. Press Tab and go back into Object mode. Select the armature and in Object Data Properties here, turn it to in front. Now our bones can be seen through the mesh. After this, let's add some more edge loops to our cube. Press Tab and go back into Edit mode. Press Ctrl R and scroll on your mouse to add some more loops. Generally, you want to have more edge loops around the areas that will be deforming. In this case, the whole length of the cube will be bending, so we want to add enough edge loops. Now it's time to skin our model to our armature. Press Tab and go back into Object mode. After that, select the object and then Shift select the armature. Press Ctrl P and choose with automatic weights. Now you can see that we have vertex groups added to our model. Each group corresponds to the bones in our armature. To see all the weights, press Tab and go into Weight Paint mode. When you click through the vertex groups here, you can see the weights Blender has automatically assigned. Now when you press Tab and go into Pose mode, you can see that our mesh deforms when we rotate the bones. Next, I just want to show you how to skin a mesh only to a specific bone. We'll add a separate mesh for that. Press Shift A and add another cube. Move it up here. Skinning to a specific bone is a bit of a different process. It's very handy for when you want to have only certain bones affect your mesh and not have automatic weights assign random influences for you. Sadly, the process is a bit more convoluted in Blender than what I'm used to in Maya, but either way I'll show you how to do it now. Like before, select the object and then Shift select the armature. Press Ctrl P and choose Armature Deform. What that does is it adds an armature deform modifier to your mesh and it links the armature to the model. But unlike when we used automatic weights, we don't have any vertex groups yet. We'll have to create those ourselves. To do that, press Tab and go into Pose mode. Then select the bone you want to have influence over your mesh. After that, go back into Object mode and select your mesh. Press Tab and now go into Weight Paint mode. Now you can see the bone we had selected earlier is active. Go here into Weights and choose Assign Automatic from Bones. Now we have a vertex group created for only the one bone we had selected. No other pesky bone influences. And that is how you do both methods of skinning. The next step after skinning is weight painting. You do that by pressing Tab and going into Weight Paint mode. We'll go in depth into weight painting mode in the next video, but I just wanted to mention this step here. Once you're done with skinning and painting your weights, you can move on to posing. Posing your armature is done in Pose mode. This is the mode where you animate your models and set all your keyframes. Let's pose our cube here. Press Tab and go into Pose mode. Here you can rotate, translate, whatever you want to do with your mesh. And if you ever wanted to quickly clear your pose and reset your rig to the default pose, press F3 and type in Clear Pose. Then here choose Pose, Clear, Transform All, and that resets everything back to the bind pose. And that is all for this video. In the next video, we'll cover weight painting in detail and we'll rig a simple character so you can see how we can apply all the principles from this video. I'll show you a bit more about constraints and we'll show you how to make controllers for your rigs as well. Thank you for watching. I'll see you in the next one. Bye!